Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x to the power of 2 over 9 to the power of x equals 81. So 9 here, 9 is equal to 3 squared, right? And 81, this is equal to 9 squared, which is 3 squared to the power of 2, which is 3 to the power of 4. So what I'm going to do is I'm going to change all these bases so that they're 3. So that makes the equation much easier to solve if you have all the terms having the same base. So we have 3 to the power of x to the power of 2 over, remember, replacing 9 with 3 squared to the power of x. And this is equal to, we're replacing 81 with 3 to the power of 4. Now, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x this is going to equal 3 to the power of 2 times x, which is the same thing as 3 to the power of 2x. And this is still equal to 3 to the power of 4. Now, if we have a to the power of m over a to the power of n, so if we are essentially dividing exponents, this would equal a to the power of m minus n. This is a basic property of exponents. So right here we have 3 to the power of x squared over 3 to the power of 2x. Well, this would equal 3 to the power of x squared minus 2x. And this is still equal to 3 to the power of 4. Now, as you can see, our bases here are the same. And if our bases are the same, then our exponents have to be the same as well, or else this equation would not be true, right? So that means that x squared minus 2x is equal to 4. Now I'm going to subtract 4 on both sides. So we're left with x squared minus 2x minus 4 equals 0. And now, as you can see, we have a quadratic equation. And what we're going to do is, well, let's use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So a is 1, b is negative 2, and c is negative 4. So we have negative b, so 2 plus or minus the square root of b squared, so negative 2 squared, which is 4, minus 4 times a, which is 1, times c, which is negative 4. And we're dividing this with 2 times a, which is 2 times 1, which is 2. Now, we're going to have 2 plus or minus the square root of negative 4 times 1 is negative 4, and negative 4 times negative 4 is positive 16. So we're going to have 4 plus 16. We're still dividing this by 2. 4 plus 16 is 20, so we have 2 plus or minus square root of 20 over 2. Now 20, this is 4 times 5, right? And 4 is 2 times 2. And what I'm going to do is I'm going to do prime factorization so that we can simplify this. So that means that the square root of 20 is equal to 2 root 5. So we have 2 plus or minus 2 root 5 over 2. And now, if I divide 2 by 2, I get 1. And 2 divided by 2 over here, this is also 1. So this would equal 1 plus or minus the square root of 5. And this would be our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this equation. So our equation here is 2 to the power of 3x minus 1 equals 3 to the power of x minus 2. And our goal here is to find the value of x. Well, what we're going to do first is we're going to take the log subscript 2 of 2 to the power of 3x minus 1. And we're doing this because remember, the log is the inverse of an exponent. So when we're taking the log with subscript 2 of 2 to the power of 3x minus 1, we're essentially canceling out our base here because these two cancel out. The log is the inverse. So if these two cancel out, then all we're left with is 3x minus 1. And we've just simplified our equation by a lot. However, what we do to one side of the equation, we have to do to the other side. Meaning, we're going to have to take the log with subscript 2 of 3 to the power of x minus 2 as well. All right, so now what we're going to do this is we're going to use an important property of logarithms, and that is the power property. And that states that if we have a power here, we could go ahead and move this in front of the logarithm. So this would be x minus 2 times log subscript 2 of 3. And I'm going to put parentheses over here. So this is an important property of logarithms, and this still equals 3x minus 1. So now what we're going to do is we're going to distribute our log with subscript 2 of 3 to this x minus 2. So this is 3x minus 1 equals, well, x times log subscript 2 of 3 is simply x log subscript 2 of 3 minus 2 times log 2 3 is simply this. All right, so now as you can see, we have our equation here. And now what we're going to do is we want to get all the x's, all the terms with x on one side. So what I'm going to do is I'm going to add 1 on both sides to get rid of 1 on this side. And then I'm going to subtract x log on both sides so that this can be on this side and all the terms with x can be on the same side. All right, so this gets us to 3x minus x log equals negative 2 log plus 1. All right, so now what we're going to do is we're going to factor out x over here. We're going to factor out x from this expression. So if we factor out x, well, 3x divided by x is simply 3 minus x log divided by x is simply just log subscript 2 of 3 and this equals, well, I could just say 1 minus 2 of log subscript 2 of 3. All right, so now let's bring this over here. So now what we're going to do is we're going to divide by 3 minus log subscript 2 of 3 so we can isolate x. So if we divide by this on both sides, we get that x here equals 1 minus 2 log 3 over 3 minus log subscript 2, 3. And this is our exact answer to this logarithm. However, people usually want a roundabout. They want a not exact answer, but an answer close to it. And this is x is approximately equal to, well, for this, we want to use a calculator because we can't get the exact answer just on paper. We need to use a calculator. So if I use my calculator here, I get negative 2.946. And this is my approximated answer. So this is how you solve this exponential equation.